So today I will be also giving this brief talk about research activities in our lab, which is called Smart and Autonomous Mobility. So I will be mainly talking about two projects today that kind of convey the general focus of our laboratory. So these are the MARE project, which is an acronym for Multi-Agent Robot Ecosystem. And the second project, which will be more detailed, is the application of such a multi-agent robot on a precision farming application. And Utopia project, I will give the details later on. So first, I would like to present the MARE project, because the MARE project essentially is constituting the backbone of a multi-agent robot ecosystem, which can realize cooperative sensing, localization, control, and cooperative mission planning in a heterogeneous and multi-agent robotic system. What we mean here by heterogeneous is that these robots may be of aerial, ground, and water robots, because by using a set of different hardware capabilities, we can utilize the most advantageous parts of different robot architectures. For example, a ground robot has higher power capacity, whereas its sensors are limited by its size, but an aerial robot is very short in terms of power capacity, but it has the advantage that it has a very easy overall sight of the landscape. So the idea here is to utilize these different combinations of sensor and hardware modalities in application areas such as agriculture, automotive, and logistic applications. And this has been a project which is funded by Boğaziçi University startup funds. And it is basically constituting the backbone of the other application-related projects that we are conducting. And this brings me to the Utopia project. Utopia is a part of a Horizon 2020 project, which is co-funded by Horizon and TÜBİTAK. And in Utopia project, we are designing a robotic platform which can collect data from farm and digitize the data to create a digital twin of the workplace. And these are the partners. Basically, the ICT Agri-Food program of Horizon 2020 aims that all the data from the farm to the fork is digitized such that optimal planning can be realized in the food chain and therewith save the costs and improve efficiency. And Utopia consortium, as part of this co-fund project, constitutes of 5 partners from 3 countries, namely Netherlands, Belgium, and we from Turkey. And out of which 3 are universities: University of Wageningen from the Netherlands, University of Antwerp from Belgium, and Boğaziçi University from Turkey. In this project, we have defined 2 use cases for the Dutch partners and the Turkish partners. And we, as Boğaziçi University, are responsible for the vineyard use case. So the application of such a precision farming platform on a vineyard. And our Dutch partners are responsible for the deployment of our Utopia framework on a seaweed use case. So for a catamaran that is operating at the North Sea and on the coastal shores, there is seaweed farming applications. But we are interested, as the Turkish partner, we are interested in the vineyard use case because Turkey actually has a significant role in the world's grape industry, but it can be improved by employing precision farming practices. One of the besides the economical motivations behind the Utopia consortium is also environmental factors are another motivation, because throughout the farming of the vineyards, growing of the grapes, there is a heavy toxic chemicals are used throughout the period, and these somehow, in a sense, later by feeding of the animals, they enter the food chain in one or the other way. So it is actually a chemical toxic load we also consume. So for optimizing the usage of water and the minimal amount of pesticides, frequent nutrition management and forecasting needs to be done by the farmer. But this can be kind of not foreseeable for the farmer. And our aim in Utopia is to generate an easy-to-use interface for the farmer, such that the mass adoption of data-rich precision farming can be done without having to educate the farmers on complex technologies. So to provide the farmer with an easy-to-use interface where this collected data is processed for them. And the concept of our use case here is presented in this slide. So an automated ground vehicle in coordination with an aerial drone collects the image from the farm, and it will create different layers of information by using this data, like 3D occupancy maps, 2D maps for path planning tasks, and then push them into a database where some monitoring about nutrition, water, humidity, etc., or other parameters can be stored, and a digital twin of the vineyard is then created. And the farmer can then subscribe with this digital data to some context broker over the cloud and have some forecasting or estimation, yield estimation information provided to them. And we are building a structure in terms of the network communication, such that this can also be easily employed by our Dutch partners for the seaweed use case scenario. Okay, I think I am out of time. Thank you very much.